Hi guys, welcome to today's class. Nice to have you in today's class. Okay, today we are looking at polygons. Okay, just give me a minute. Let me share the live class to students on my WhatsApp group. So once I'm done, we'll start. Okay, that's the first one. And then second group. Third group. Okay, I think now we can start. Okay, good evening everyone. So today we're looking at polygon. Polygons. So the first thing we need to know is, what are polygons? What are polygons? So a polygon is a plane shape that has at least 3 sides and 3 angles. Let's write that down. That has at least, I think this markers are 3 sides and 3 angles. So whenever you see a plane shape that has at least 3 sides and 3 angles, that plane shape can be called a polygon. Okay, so there are different types of polygons. Polygons can be classified based on the number of sides and based on the size of the angles and the length of the sides. So polygons can be classified based on one. So you can classify polygon. The first way to classify polygon is based on the number of sides. So we're going to look at the different types of polygons based on the number of sides of the polygon. And the second way to classify polygon is the length of the sides and size of angles. So these are the two basic ways of classifying polygon. You can classify polygons based on the number of sides the polygon has. You can also classify polygon based on the length of the sides and the size of the angles. So we're going to look at these two classifications. Okay, so before you start solving, you need to understand the basics of the topic. So that's what we are trying to do. We want to understand the basics of the topic. So now we understand that a polygon is a plane shape that has at least 3 sides and 3 angles. You can also see that polygons can be classified based on the number of sides and also based on the number based on the length of sides and size of angles. So let's look at the classification. Okay, so let's look at the first way of classifying it. Number of sides. So number of sides. So the smallest type of polygon is triangle. So a triangle is a type of polygon that has 3 sides and 3 angles. So whenever you see a polygon that has 3 sides and 3 angles, we call it a triangle. So a triangle is a type of polygon. B, quadrilateral. 4 sides, 4 angles. So a polygon with 4 sides and 4 angles is called a quadrilateral. Examples of quadrilateral are rectangle, square, kite, trapezium, rhombus, and so on. Parallelogram, all these 2D shapes have 4 sides and 4 angles. Therefore, they are all called quadrilateral. The next one, C, pentagon. So a pentagon is a polygon with 5 sides slash 5 angles. So a pentagon has 5 sides and 5 angles. D, hexagon. So remember, this classification is based on the number of sides of the polygon. So a hexagon has 6 sides, 6 angles. Okay, so a hexagon has 6 sides and 6 angles. Sorry, I don't understand what you said. But you did not give us times to copy. Oh, sorry, I didn't. Yeah, probably you just joined the live. After we were done with the definition, I think I left it on the board for about 2 to 3 minutes. But when we are done with this one, I'm going to leave it. Okay. Sorry about that. So the next one, E, heptagon. A heptagon is a polygon with 7 sides, 7 angles. So a heptagon is a polygon with 7 sides and 7 angles. And next, we have octagon. So an octagon has 8 sides slash 8 angles. So this is important because in some questions, you might just be told that a pentagon, you might just be given the shape and you might not be told the number of sides. So if you are given a question and you are told the shape involved in that question, but you're not told the number of sides, and you don't know the number of sides, you might just end up failing the question because you don't know that, for example, a heptagon has 7 sides. And then you are given a question concerning a heptagon, and then you fail it because you don't know that a heptagon is a polygon with 7 sides. So that's why you should know the different types of polygons based on their number of sides. Okay, so G, nonagon, 9 sides, 9 angles. So a nonagon has 9 sides and 9 angles. And then finally, H, decagon. This has 10 sides, 10 angles. So what we've done is we've classified polygons based on the number of sides. So this classification of polygons is based on the number of sides. So whenever you see a polygon with 8 sides, that polygon is called an octagon. A polygon with 6 sides is called a hexagon. So you should know the different types of polygon and how many sides they have. Okay, so that's the first thing. But for those that missed the first thing I wrote, I introduced the topic by saying that a polygon is a plane shape that has at least 3 sides and 3 angles. So that was the part I have cleaned before writing this. So in case you don't write very fast, you can just take screenshots so that you can fill up the spaces at the end of the class. Okay, because I don't want us to have too many breaks where I have to wait and then start again after some minutes, because some persons watching the replay might not be patient to have those breaks. Okay, so can we continue? Someone should tell me if we can continue. Can we continue now? Thank you guys for joining the live class. If you're from the group, please indicate that you're from the WhatsApp group. Okay, I think I should continue. So before we continue, we've looked at types of polygon based on the number of sides. So now we are going to look at types of polygon based on the length of the sides and the size of the angles. So types of polygon based on length of sides and size of angles. Okay. So the first type of polygon based on the length of sides and size of angles is called regular polygon. Regular polygon. Sorry. Regular polygon. So a regular polygon is a polygon that has equal length of sides and equal size of angles. That means for a regular polygon, the length of all the sides are equal, and the length and the angles are also equal. Okay, so okay, so a regular polygon, this type of polygon has angles of equal sizes and sides of equal length. So whenever you see a polygon and you see that all the sides are equal, all the sides are the same, and all the angles are the same, that type of polygon is called a regular polygon. So this regular polygon can be a hexagon, a pentagon, it can be any type of polygon based on number of sides. But if the angles are equal and the sides are equal, then it is a regular polygon. For example, let's draw a regular pentagon, for example. Okay, sorry, this is a hexagon. 1, 2, 3, 4, 5, 6. So we want to draw a regular hexagon. For a regular hexagon, all the sides will be the same. So if here is A, here will be 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 A. So the length of each of these sides will be equal, and also the angles. If here is B, here will be 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 B. So when you have a a hexagon like this can be called a regular hexagon. It is a hexagon, but it is a regular hexagon. Okay, because we've counted the sides, we've seen that it has 6 sides, therefore it is a hexagon. Next, we saw that each of these sides are the same and each of these angles are the same, therefore it is regular. So combining regular and hexagon, we have a regular hexagon. So you can have a regular quadrilateral, you can have a regular pentagon, you can have a regular octagon, right? So you can have a combination of that. Okay, so you can classify a polygon based on the number of sides, then you classify the polygon based on the equality of the sides and angles. Okay. Good evening, Peace Sunday. I'm doing great. How are you? Hope you're also doing well. Okay. So we've seen a regular polygon, what a regular polygon is. Before we go further, among the quadrilaterals, we said earlier that quadrilaterals are polygons that have 4 sides. Among quadrilaterals, the only quadrilateral that is a regular polygon is a square, because a square has equal sides and equal angles. A rectangle is not a regular polygon because although it has equal angles, it does not have equal sides because two of its opposite sides are equal. I just wanted to mention that. Okay, so the next one, 2, is irregular. Irregular polygon. So an irregular polygon is a polygon that does not have equal length of sides and equal size of angles. So when you look at an irregular polygon, all the sides are not equal and all the angles are not equal. So whenever you come across such a polygon, that polygon is an irregular polygon. So an irregular polygon can be a pentagon also, it can be a hexagon, it can be a nonagon, it can be a quadrilateral. But if all the sides are not equal and all the angles are not equal, then that polygon is an irregular polygon. Okay. So now we've seen what a polygon is. We've been able to classify polygons. The next thing we're going to do, we're going to see how to calculate sum of angles in a polygon. Sum of angles in a polygon. So I'll be wiping this off in 1 minute time. Sum of angles in a polygon. That's the next thing we're going to be looking at. Okay. So this, you can also share this live class with your friends. If you have anybody that you would like to join you, you can also share the link to join the WhatsApp group with any serious student that you know around you. Okay, you can join the WhatsApp group. So let's continue. We've seen what a polygon is. We've seen the different types of polygon. Now I want to calculate the sum of angles in a polygon. Let's do that. Okay, sum of angles in a polygon. So sum of angles in a polygon means add all the angles of the polygon together. I think we should specify interior angles because we also have exterior angles. Some of interior angles of a polygon. So polygons have interior angles, they also have exterior angles. So our focus now is on interior angles. Okay. So let's say we have I'm just giving an example before we start. So let's say we have this, and this is A, B, C, D, E, and F. So sum of angles means adding all these angles together. So there is a formula that you can use to find the sum of angles in a polygon. And that formula is n minus 2 times 180 degrees. So the formula for calculating the sum of angles in a polygon is n minus 2 times 180 degrees, where n is equal to the number of sides of the polygon. So n is equal to the number of sides of the polygon. Okay? N is equal to the number of sides of the polygon. So we can calculate the sum of angles in a triangle. We can calculate the sum of angles in a quadrilateral. We can calculate the sum of angles in a pentagon, hexagon, heptagon, octagon, nonagon, and decagon using this formula. So let's start. Let's calculate the sum of angles in a triangle. So we're going to use this formula to calculate the sum of angles in a triangle. Remember, the number of angles in a triangle, the number of sides of a triangle, n is equal to number of sides. So the number of sides in a triangle is 3 sides. So that means using this formula, our n is going to be 3. So we know that n minus 2 times 180, where n is equal to 3. So we are going to replace n with 3. So we have 3 minus 2 times 180 degrees. And 3 minus 2 is going to give us 1. So we have 1 times 180 degrees. And that will give us 180 degrees. So that means the sum of angles in a triangle is equal to 180 degrees. So why is this important? Sometimes you might be given 2 sides of a triangle and you're expected to find one side of the, sorry, you're given 2 angles in a triangle. If you have a triangle like this, and you're given these 2 sides, and you're expected to find this third side. So if you know these 2 sides, but you don't know this side, so since you know that the sum of angles in a triangle is equal to 180 degrees, you can simply add these 2 sides together and subtract it from 180 degrees. And that will give you the side you don't know. Okay, so that's the importance of knowing the sum of angles in a particular polygon. So we've seen the sum of angles in a triangle. I'd like somebody to solve sum of angles in a quadrilateral. Another person solves sum of angles in a pentagon, while I solve sum of angles in a hexagon. Okay, let me just Astro, nice to see you. Um, are you part of Astro? Are you part of the WhatsApp group? My WhatsApp group, sorry. Okay, so let me wipe this off. Let's look at sum of angles in a hexagon. As I said earlier, someone should calculate sum of angles in a quadrilateral, and someone else should calculate sum of angles in a pentagon. It's not on my bio on YouTube, but it's on my bio on TikTok. Probably I'm going to do that after this live. I'm going to put the link to join my WhatsApp group on my bio on YouTube. But up till this point, it's not there yet. Okay, so sum of angles in a hexagon. Has anybody done the sum of angles in a quadrilateral? Thank you so much. The sum of angles in a hexagon has 6 sides. So for a hexagon, n is equal to 6. For a hexagon, n is equal to 6. And we know that the formula is n minus 2 times 180 degrees. So where n is equal to 6, so we have 6 minus 2 times 180 degrees. 6 minus 2 is going to give us 4, so we have 4 times 180 degrees. 4 times 180 degrees is equal to 720 degrees. Okay, so that means the sum of angles, correct, sum of angles in a quadrilateral is equal to 360 degrees, correct? 360 degrees. 360 degrees. That's correct. Okay. So now we've seen the sum of angles in a hexagon. Hexagon has 6 sides. So we replace n with 6. And then 6 minus 2 gives us 4 times 180 gives us 720 degrees. So sum of angles in a hexagon is equal to 720 degrees. Okay, so we skip heptagon. Let's go to octagon. Sum of angles in an octagon. So we know that the number of sides of an octagon is 8. So we are replacing n with 8. N minus 2 times 180 degrees. So instead of having n, we're going to have 8. So 8 minus 2 times 180 degrees. 8 minus 2 gives us 6. So we have 6 times 180 degrees. So 6 times 180 degrees is equal to 1080 degrees. Okay. So that means the sum, correct, pentagon, the sum of angles in a pentagon is equal to 540 degrees, correct. So sum of angles in an octagon is equal to 1008 degrees. Okay, so this knowledge is going to help us to find a missing angle in any of the polygons. Okay, so let's use this knowledge to solve missing angles in a polygon. Let's use this knowledge to solve missing angles in a polygon. But before we do that, we can use this knowledge to find the size of each angle of a regular polygon. We can use this knowledge to find the size of each angle of a regular polygon. Okay, so let's do that. Let me wipe this off. So we want to look at the size of each angle of a regular polygon. Remember that a regular polygon has all the angles equal, right? So all the interior angles of a regular polygon are equal. So let's say we want to find the size of each angle of a regular triangle, for example. So because the formula to calculate the size of each angle of a regular polygon is n minus 2 times 180 degrees all over n. So when you know the sum of angles in the polygon, you simply divide by the number of sides because you know that each of the angles is equal. So once you know this total angle, all you need to do is divide it by how many sides the polygon has, or how many angles the polygon has. That will tell you the size of each angle, okay? Because a regular polygon has equal angles. All the angles have equal value. So if you want to know each of those angles, all you need to do is divide by how many angles they are. So for example, so let's calculate the size of each angle of a regular triangle. By the way, a regular triangle is called an equilateral triangle because for an equilateral triangle, all the sides and all the angles are equal. So using this formula, we have n minus 2 times 180 degrees all over n. And we know that for a triangle, n is equal to 3. So we're going to fix it here. We have 3 minus 2 times 180 degrees all over 3. 3 minus 2 times 180 degrees all over 3. So 3 minus 2 gives us 1. So we have 1 times 180 degrees all over 3. This will give us 180 degrees all over 3. So 180 divided by 3 is going to give us 60. So that means each angle of a regular triangle is equal to 60 degrees. The size of each angle of a regular triangle is equal to 60 degrees. Okay, so let's continue. Hope we can continue, guys. Hope you can continue. Can we continue? I think we can. So we've seen how to calculate the size of each angle of a regular polygon. So we've considered a triangle. Let's consider a pentagon. Let's consider a pentagon. So a pentagon has 5 sides. So that means we have n minus 2 times 180 degrees all over n, where n is equal to 5. So our value of n is equal to 5. So this means 5 minus 2 times 180 degrees all over 5. 5 minus 2 gives us 3, so we have 3 times 180 degrees all over 5. So 3 times 180 degrees is going to give us 540 degrees. So we have 540 degrees all over 5. 540 degrees all over 5. 540 degrees divided by 5 is going to give us 108 degrees. This means for a regular pentagon, the size of each angle is 108 degrees. Each of the angles of a regular pentagon will be 108 degrees. So I'd like you guys to solve this question and tell me the answer. Okay, so I'd like you to calculate this in 3 minutes. The size of each angle of a regular octagon. The size of each angle of a regular octagon. I'd like you guys to calculate that in 3 minutes. 3 minutes, 3 minutes, 3 minutes. Less than 2 minutes left. Less than 2 minutes left. One minute, 1 minute, 1 minute left. Calculate the size of each angle of a regular octagon. Thirty seconds left. Okay. 135 degrees. Okay, good. 135 degrees. Okay, 135 degrees. Correct? Correct. Because the sum of angles in an octagon is 1080 degrees, 1080 degrees, and then when you divide 1080 degrees by 8, you're going to get 135 degrees. Correct? Okay. So in today's class, we've learned about what a polygon is. We've seen the different types of polygon. We've also looked at how to calculate sum of angles in a polygon. We've seen how to calculate the size of each angle of a regular polygon. Now we are going to consider how to calculate missing angles in a polygon. Okay, I, I, I am hoping that we'll do that in the next 15 minutes. Let me get some questions. Just 1 minute, let me get the question from my phone. Okay, so let's look at the question now. Okay, so if you're given a question like this and you're told to find the value of x, so first of all, you ask yourself, what type of polygon is this? This polygon is a quadrilateral because it has 4 sides and 4 angles. So a quadrilateral with 4 sides and 4 angles is a polygon with 4 sides and 4 angles is a quadrilateral. Next, what is the sum of angles in a quadrilateral? So if you don't know the sum of angles in a quadrilateral, you can just use the formula we used earlier to find the sum of angles, which is n minus 2 times 180 degrees. Okay, that's if you don't know the sum of angles in a quadrilateral. So n is the number of sides. So we have, sorry, n is equal to 4. So we have 4 minus 2 times 180 degrees. 4 minus 2 gives us 2 times 180 degrees. And 2 times 180 degrees gives us 360 degrees. So now we've known the sum of angles in a quadrilateral. That is if we did not know it already. So what can we use this knowledge to do? All we need to do is sum of angles in a quadrilateral means when you add all these angles, you're expected to get 360 degrees. So if you know 3 of these angles, but you don't know this angle, you can easily find this angle, right? So this means x plus 120 degrees plus 70 degrees plus 60 degrees is equal to 360 degrees. That's what this means. So the knowledge of this will make us get the value of x. So 120 degrees plus 70 degrees gives us 190 degrees. 190 degrees plus 60 degrees gives us 250 degrees. So that means x plus 250 degrees is equal to 360 degrees. So x, you move the plus 250 degrees to the right, we have 360 degrees minus 250 degrees. So this means x is equal to 360 minus 250 is going to give us 110 degrees. So the knowledge of the sum of angles in a quadrilateral has helped us to find the value of this missing angle. So that is the benefit of knowing the sum of angles in a particular polygon. Okay. So while you write that down, I'll get the next example, which will be the final example for today's class. So let's look at another example. Okay. So this will be the final example for today, for today's class. So now we are told to find the value of x in this diagram we have here. Looking at this diagram, it seems that we have two missing angles. We know this angle, we know this angle, we know this angle, we know this angle, but we don't know this angle. And it seems that we don't also know this angle. But this angle has a sign here, and this sign tells us that this angle here is 90 degrees. Okay, so because you can see this, we don't need to be told that this is 90 degrees. We don't need to see 90 degrees here. This sign already tells us that this is 90 degrees. Okay, so how many sides does this triangle, sorry, how many sides does this polygon have? How many angles does this polygon have? Let's count. 1, 2, 3, 4, 5, 6. This polygon has 6 sides and 6 angles. Therefore, it is a hexagon. So that means we are dealing with a hexagon. Okay. So now we need to know the sum of angles in a hexagon by applying the formula n minus 2 times 180 degrees. So n for a hexagon is equal to 6. So 6 minus 2 times 180 degrees. 6 minus 2 gives us 4. So 4 times 180 degrees. That means the sum of angles in this hexagon is 720 degrees. 720 degrees. This means that if we add this angle, this angle, this angle, this angle, this angle, and this angle, we're expected to have 720 degrees. So if we know all these angles, we can simply find this angle by adding these ones up and subtracting it from 720 degrees. Okay. So for us to do that, I'm going to wipe this off. Because of space, I'm going to wipe this off. Can I go ahead? Can I go ahead to wipe it off? Okay, I will do that. So we already know that the sum of angles in this hexagon is equal to 720 degrees. This means that x plus 127 degrees plus 40 degrees plus 202 degrees plus 90 degrees plus 150 degrees is equal to 720 degrees. Okay. So the next thing we need to do is add all these angles together. So when you add all these angles together, you are going to have 609 degrees. So x plus 609 degrees is equal to 720 degrees. So next, we move 609 degrees to the right. We have x is equal to 720 degrees minus 609 degrees. So when you do 720 degrees minus 609 degrees, you're going to have 111 degrees. So that means x is equal to 111 degrees. That becomes the value of x. That becomes the value of x. So it is quite easy to find a missing angle in a polygon when you know the sum of angles in that polygon. So the first thing you need to know is what is the sum of angles in that polygon. Then once you get that done, you just add all the known angles and subtract it from the sum of angles in that polygon. And that gives you the answer. Okay. So whenever in our next class on polygon, we're going to look at sum of exterior angles in a polygon. We're also going to look at the number of diagonals, how to calculate the number of diagonals in a polygon. I think we have spent 1 hour or about 1 hour in this class, and that is my time limit. Thank you guys so much for being here up to this point. If you have any questions, you can leave it in the comment section of the video after the video has been uploaded. Also, you can join our WhatsApp group if you are not in the WhatsApp group. You can also become active in the WhatsApp group. Okay, so that means if there's any question that is asked in the interactive group concerning Polygon, you should be the one to solve it for anybody that needs help on that, because you have already learned about it. Okay. You can also refer your friends, your family members to my YouTube channel. If you want to get any of these videos that we've done a uh, as a lesson, you can just go to the playlist of my YouTube channel. Once you go to the playlist of my YouTube channel, you'll see all those video tutorials that we've done and the ones that we'll also do in the future by the grace of God. Okay. So thank you guys. Thank you for staying till now. See you in our next class. Have a wonderful night rest. Bye. Adios.